So there we go. Just regardless of what happens, just make sure you learn something, okay? So the odds of a student passing Mr. D's class are 14 to 1. The way it's written, that tells it that this represents the instances of passing. Therefore, this is not passing, right? Just the way it's written. State the probability of a student passing. So you would go 14 over 14 plus 1. So it's 14 over 15. The reason I'm going to give you 2 marks today is I'm going to give you 1 for each number. Okay? So if you have 14 out of 15, you get 2 out of 2. If Mr. D teaches 95 grade 12 students in a year, how many will pass his math test? You're making a prediction. So you go 14 over 15, and you multiply that by 95. You get 88.6, and that keeps going. So as long as you answer 88 or 89 students. Okay. All right. Next, the probability of Sisler's volleyball team winning an upcoming tournament is 4 out of 15. So this is already a probability. Okay, it's a dash, not a colon. State the odds of Sisler winning the tournament. Right. You want this, and so this would be 4, and then 15 minus 4. So that'd be 4 to 11. So today, just today, I'm going to give you 1 mark for each correct number. So if you've got the 4, you get 1 out of 2. 4 to 11 to get the 2 out of 2, because we're still learning. But down the road, it has to be, both numbers have to be correct to get any marks. Okay, let's keep going. State the odds against Sisler winning the tournament. All you have to do is whatever you have up here needs to be flipped. Okay, that's the only condition here. Even if you got this all wrong, if you're flipping that, you get 1 mark for a step. Next, 4 blue, 6 green, that's 10 already, 5 red, so 15 total. It's making, and when it's probability, that's a good chance you're going to have to do that anyways. State the odds against drawing a blue marble. So odds against blue. That means that blue will go here, therefore not blue shows up first. Okay, so I grab my 4, and in this case you can either just go 6 and 5 is 11, or you go 15 minus 4. Regardless, it's 11 to 4. I should pick different numbers. It's exactly the same numbers as question 2, right? But anyways, so 2 marks here, 1 for each correct value in the correct place. State the odds of drawing a green marble. Because it's odds of green, we know that the first number would be the number of greens and then not greens. So I have 6 greens, and you have 15 minus 6, so it's 6 to 9. Okay, 1 for each correct number. State the probability. Okay, you gotta watch out. Probability of drawing a red marble. So then you would just go, well, we have 15 total. And reds, we've got 5. So I go back to the original bag, so to speak, and just get my numbers out of that. 1 mark for each correct number. The odds against drawing a red marble. So odds against means that red will be here, so therefore non-red there. I always like to have letters before numbers if possible. So I have, you can base it on the original. So I have 5 reds, and this would be 15 minus 5. So it would be 10 to 5. Okay? Or 2 to 1 if you reduce this. Okay? It's fine either way. The Jets play against the Senators. The odds of the Jets winning would be 5 to 4 because it says odds of winning. This represents the wins. This represents the losses. Okay? State the odds against winning. It's the exact same event, but it's saying against, so we just flip the numbers. That's it. State the probability of the Jets winning. So that'd be 5 over 5 plus 4. So that'd be 5 over 9. So 1 mark for each correct entry. state the probability against the Jets winning. So basically probability of not winning. I can do this, right? Proper notation. Still going to be out of 9, but in this case it's going to be 4. Or you can go 9 minus 5, right? 5 represents the wins. So that's 4 over 9. Okay, so 1 mark per correct entry. So we have 19 marks. Let me just double check. 2, 4, 5, 7, 9, 11, 13, 14, 16. 16 and 3 is 19. Yeah, got 19 on this page. Lots of marks hovering all over the place here, but it's probably not going to be the case on a test because a lot of the 2 markers are going to be just 1 markers. Okay. All right. Back side. So here we talk about experimental theoretical. Okay, Laura's spinning the wheel and she spins it 25 times. You can either just go by this or add these up. You get 25. Okay, so you might have to get your total by just adding the number of trials or experiments. So we use this for experimental probability. We'll use this every time it says theoretical probability. Okay, so here we go. The probability of the spinner landing on purple. Theoretically speaking, it's 2 out of 5. Okay, so 2 out of 5. Oh, it says fraction and decimal. Okay, it does say that here. So that'd be 0.4. So 1 mark for that. Experimental. Purple, there's 4 instances out of 25. And that would be 0.16. Okay, so this is how we're going to mark this one. Okay, are you ready? Each of them is going to be worth 1.5. So I give you 1 for the correct fraction and then half for the decimal. 1 for the fraction, half for the decimal. So if you get the decimal wrong, like if you round incorrectly, just take off half a mark. That's how we're going to go today. The probability of the spinner landing on red, so it's all about red. In theory, there's only 1 out of 5. Okay, so that'd be 0.2. Again, 1.5 marks for this box. And then again, 1.5 for this experimental. So there we have 7 reds out of 25. That gives us 0.28. 0.28 if you round to 2 decimals. If you round it to 4, today I'm just going to say if you think you're right, give yourselves a half mark. If you round to 3, 4, 5, 6, it doesn't matter. It's not dollars, right? Then you can round to more than 2. It's fine. Okay, so 1.5, 1.5 here. Next, state the odds of the spinner landing on purple. If it's odds, you want that, right? For both of them. So in theory, we go by purple. You can go by this, or you can go back to your theoretical here. The probability is right there. So it's 2 to 5 minus 2. So it's really 2 to 3. Because remember, we're talking sections that are purple, sections that are not purple. That's what we're going with. Experimental. Morning. I'm going to use this right here. I'm going to say 4 and then 25 minus 4. 4 to 21. Just 1 mark each. Okay. So this means this is 3. This is another 3. That's 6, 7, 8 so far. And then this last question is going to be worth 2 marks. Okay. So 8 and 2 would be 10 for this page. I'm going to already write that down so I don't forget. Okay. If Laura spins the spinner 1,850 times, how many times would she expect it to land on yellow? Okay, so that's a prediction. And when you have both probabilities, you're going to use theoretical. So yellow, what are we at? 1 out of 5? That's going to give you 1 mark already. And you multiplying it by 1850 and getting an answer It's, by the way, 370 times. You get another mark for that. So if your probability is wrong, so let's say you used 8 over 25, right? That's a -1 right away. But I would still give you another mark for the fact that you're multiplying your probability by the 1850. That's another concept. So you would still get 1 out of 2. Okay. So 10 and 18, no, 19, right? 10 and 19. We'll make this whole thing worth 29 marks. So at the very top, wherever it says there, just cross it out. It says 27, so just cross that out and just make this out of 29. Maybe put today's date on there, because then you can go back. I post some of the AC corrections.